Ladies and gentlemen, boys and girls, children of all ages, we are live. For the thousands of Nuggeteers in attendance, okay, possibly one family member, and the millions of Nuggeteers watching from around the world, okay, maybe 5 from Wisconsin, 2 from Illinois, and 1 from Texas. Temporarily Offline Radio presents Ham Nuggets, the fastest hour in ham radio YouTube. 60 minutes is 60 minutes. Yeah, I know. And now, here is your host, the man, the myth, the legend, if even in his own mind, KM9G, otherwise known as T.O.
I feel like I have to burp. It's really hard to do an intro when you're like, howdy everybody, this is Steve, KM9G, and I'm just a little, unfiltered at this moment. I've got my friends here, Chuck and Jim, and the whole time that intro was going, I'm like, please just get it out. Nope. Thanks, Hayden. So welcome everybody. We are going to play around on stream today. I got this thing. Let me pull it in. We'll do a quick look. I got some fancy camera stuff going on today. I've got 2 cameras going into the stream from here, and I've got like they're right there. One right there, one right there, which is that one right there. Interesting stuff. Anyway, that's all like technical stuff. So this is the step attenuator. I drove all the way out to Yuma, Arizona from Luck, Wisconsin, just to get this, just to bring it to the show for you guys to see. And I know what it's supposed to do. I have a potential use case test scenario. I've got some stuff here to play with it. I got a tiny SA to play with. I have a nano VNA to play with. And Jim's got his scope. I mean, Jim doesn't have the attenuator, but we can play. Jim's got a decade box. Jim, tell us what you got.
So I have, I can't move it onto the camera because there's like some sketch. I've got the tap that we showed yesterday on Coffee and Ham Radio.
Oh, excellent.
And I cut out the 3300 ohm resistor out of it.
Welcome.
And I have a decade box, which is a box that lets you just switch resistances. So we can move resistance, and we're essentially just able to switch through different resistors on that tap box, and we can look at what it does on the scope.
Yeah, so a decade box is supposed to have like 10 different resistance values or 10 different capacitance values, hence the name decade. Or supposed to have 100.
I don't know. This is the cheapest decade box that Amazon sold, so
How many you got there?
It's got 2 ranges. It has an ohms range and a 10K ohm range. So I think the decade is magnitude orders. So on a fancy one, a real one, it'd be like ohms, K ohms, 10K ohms, 100K ohms.
That makes
something
sense.
like that. Something like that. I think it's back powers of 10.
All right, so Phil in the chat is saying no communications in cigars today. I think that there is a communications in cigars. I saw one scheduled earlier. Did John unschedule it?
Did you? I don't know. I can check. I will check that for you.
You will chuck that for us? Check?
I would check it, Chuck.
I was going to toss it over to Chuck to do
check.
Chuck's intro,
Have
but
Chuck
Chuck's
check.
a little busy right now. So while Chuck is looking for that, I'm going to switch over and get this thing on the big screen here.
Now, how much did you pay for a 41 dB step attenuator there, Bucky?
I want to say this thing was like $12. Not bad at all.
Excellent. That's excellent.
So I got this, and then on a future show, I got this piece of Elecraft kit over here. This is going to be, you can tell it's Elecraft because it's in the fancy Elecraft packaging.
It's a pink bag.
It's a signal reference generator, and you plug a coin cell into it, and you plug this end into your radio, and you turn it on, and it broadcasts a signal at 7040 megahertz, and then you're like, oh, my transceiver works. So
That's
you
swank.
can EDC this thing and test transceivers when you're out on the go at the Hamfest.
I wonder. I guess they sell that standalone. That's pretty cool.
Yeah, it's a kit that you can build.
I don't see anything for John tonight. I see something for the 4th.
Okay.
Yeah, lawnmower is saying the only thing John has scheduled is for next week.
Excellent.
Yeah.
So if we go into double extended overtime again, I hope not. But if we go into double extended overtime again, we're not getting in
Mary.
anybody's way.
That was the last time I was here, huh?
Yes, it was, Chuck. We blazed some trails that night, my friend.
It was
Just
mostly
blame it on
your
me.
fault, Chuck. Yeah,
Steve, can I say thank you to Steve?
you can say
While
thank
he's
you to
here?
Steve.
Steve, I want to thank you.
solo.
I found out, everybody. So I got this today in the mail, and this is from
Ooh.
Steve.
Fancy, I like that.
KO4AFL.
That's nice.
I had to do some. My wife I dissected the package to see who it was from because they'd cover up everything. So
He didn't trust it. Looked awful sketch with Steve.
Steve,
Ander-
did you make that on it? Did you do that? Because it looks good.
it looks good. It's great. Can I
Does it look
finish
good?
on
Yeah,
it?
then I made it.
Oh, okay.
Awesome.
All right.
Oh, look at this.
All
This
right,
is
so we took
fancy.
the back
Well,
cover
that
off.
was my
It's got a
first
nice
question. Are
circuit
you
board.
going to gut that bad boy? That's right.
Oh, I'm already gutting it, my friend.
Dang,
it
we
say?
serious.
It almost looks like it's an LED light when it has words there almost. Huh?
Oh, look at that. Mandrix QRP kits. I think that the camera. I think StreamYard's messing with the camera.
I can't see it.
So it says
I can't
Mandrix
quite read that.
QRP kits. www.qrpkits.com. Attenuator 6. So this is the 6th revision of the Attenuator. Let's keep digging. Somebody pull up qrpkits.com. Let's see if there's anything interesting there or if it's lost to the ether.
Checking it.
So these are different screws for that portion. Man, it stinks that StreamYard's jacking up the focus for you guys because I can see it perfectly on my preview.
It says, welcome to Pacific Antenna /QRP kits.
Excellent. So is there a product they have on their website that looks like this, and how much did it originally sell for?
Well, let's see. There it is right there. 41 dB step RF attenuator. And this is much smaller than that one. It's a square form factor or a much shorter, fatter rectangle. Usable from DC to over 200 megahertz.
If only there was a way you could share your screen so we could all see it.
I'm doing that. Sorry. My bad, dog. You were asking questions, and I was trying to come up with answers and just,
Use both hands, man. So we have the ground lug from the BNC connectors running to a common rail that goes across the top of the circuit here. And then we have the center conductor that goes through each of the switches and then out the other side. I'm going to try and flip this over gently.
I was sitting there talking, muted.
Okay, well, I'm scared. I'm scared. If you want,
Let's
You're
share
scared?
that out
I'm
real
scared.
quick and solo it. Yeah, so it's a lot smaller now.
yeah, it's a different form factor, and they have, I mean, wow. You know,
Nice.
I've met these guys before at Pacificon.
have you?
Yeah.
Well, they have. This looks interesting. I'm gonna have to spend some time going through this because I see a lot of really interesting kit potential. I mean, there's RF amplifiers, there's
Nice.
filter kits. This guy. So I never did find a price on it. Let's.
I've heard of that Tenna dipper before.
The Dipper?
Yeah.
What I didn't see was a price.
3D printed case. Nice. There you go.
$25.
So I got it for half price.
Half price. That's not bad. Then that's a nice looking little kit. I mean, there's not much to it. A step attenuator is just resistors with a switch.
Yep,
Should
that's all
be.
you're doing is you're switching in and out the different levels of resistance here. And the reason why this is 41 dB is because you can switch them in. So let me get it put back together and flipped over.
Well, actually, put it up on the screen, Steve, so we can see it real good. So, yeah, just resistors. There's no capacitance in there at all.
Right.
Yeah. Okay.
Oh, that's
Sweet.
why it's easier to read on here. I was trying to read through the circuit board. I didn't even know it.
Derp. Derp,
You
derp.
were reading it backwards, too?
I'm doing it upside down and everything. I'm doing it in real time, folks. All right, let me get these screws back in.
So yeah, this looks interesting. They have transmitter kits, transceiver kits,
Yeah, they have a lot of cool stuff. Oh, man. There it goes. They are out of Fayetteville, Arkansas.
Nice. Arkansas does not sound like a Pacific place.
They may have been. Reason I was looking at it, I thought they were from California. That they're
Well,
from
with a
down-
name like Pacific, I would expect that they were on the West Coast. Yeah.
And they may have been at that. That was like 4 or 5 years ago, so they may have moved. Maybe, who knows?
To a tax-friendly state or something.
Yeah, maybe. Hey,
Apes
we
up-
have no problem
Apes in the
taxing you.
chat.
Awesome.
Oh,
Abe.
of course he is.
So
He wants to be
Todd
here.
says if you're going to do it, you might as well do it the hard way. That's like the ham's motto, right?
That's right.
If it can be done easier, I don't want to do it. I don't want any part of that.
Where are you seeing that? I didn't see that. I didn't see Todd.
And 3 PKJ Todd.
I do see. Never mind. I see him.
New Todd.
What was I saying? What was I saying?
New Todd and old Todd.
Old Todd's the Hawaiian Todd, right?
Oh yeah, he's something else now. He's Starlight Ranch or something. I don't know what it was.
Digital Dreamer or something? I don't know.
Digital Dreamer, maybe. Yeah.
Yeah.
I haven't seen him in a
So
while.
Scout 75's in the chat. Scout, I went to look at a park in Osceola to check out Parks on the Air, and you're listed as the first activator. Thanks, Scout. Guess I'm not going to get that one.
Stole Steve's thunder on that one.
Well, it's one of those things where you have a little pull-off parking lot, gravel on the side of the highway. County Road S.
But that's like the wildlife management area here that's close to me.
Yeah.
Except they shoot in the wildlife management area, so I don't want to get too far
Well,
off.
see, Todd's got it. He's WH6DWF is the other Todd. Todd knows what Todd we're talking about when we're talking about the Todd that's not this Todd that we're talking about right now.
Right.
Don't ask me to do that one again. All right. So you can see on the front it's got this bypass and this attenuation switch. And I guess before we get too far into this, what would you use a step attenuator for? I got some ideas. Chuck, what do you use one for?
If you want to knock down like a signal, right?
And why would that be
Some
helpful?
people use them in amps to. I know some amps can be modded where you take away the attenuation so that 5 watts in is 1500 out. I do know that for a fact. Need another thing? I think
Well,
you
I think
can
Ham
attenuate
DeLorean's got your
signals.
back. He says RFI finding or direction finding.
Fox and Hound action.
Well, it depends on what you want to do.
Yeah. So now, the last time I went on a fox hunt, the fox was one of these little 5-watt Baofeng radios was actually the fox. But once you get up close to it, you're there, and the signal is all around you. You're inside the bubble of RF, if you will. And so anywhere you point your antenna, you're getting a signal. So I wasn't skilled enough at the time. There's a couple of things you can do. One is you can go off frequency a little bit, and that would attenuate the signal. The other one is you can remove the antenna, and that would attenuate the signal. And then you can put your body between the antenna and where you think the source is to kind of create a null and all kinds of stuff like that. But it was still too strong, so I just went over and picked up the Fox and moved on with my life at that point. But if I had one of these, what I can do is I can add attenuation a couple of steps at a time. And the reason why this is 41 dB is, I mean, you kind of can probably get it here. I start off at 20. I add in 10 more, that's 30.
30.
I add in 5 more, that's 35. I add in 5 more, that's 40. And then 1. So there's that.
Dang.
Can't stop the signal.
How'd
So
you
I can
figure
do
that
1.
out?
I can do 2. I can do 3.
Ooh,
I can
look at that.
do
5.
4. I can do 5, 6, 7, 8. Now we're getting. I'm running out of fingers.
Oh,
here.
math on stream. Math on stream. Stop.
9,
I'm waiting for him to get stumped.
10.
Wait for him to pull his feet up
Can
on
I-
the table.
Can I do 11? 11,
Here,
12,
here. Use these.
13.
There's 10.
How far can I go? 14, 15, 16,
Hayden is in the
17,
stream, and he said what I was
18,
fixing to say. We say that in Alabama. We're fixing to do
19,
things.
20.
It will also help if you're on HF.
20,
All your HF
21,
radios
22.
have some sort of built-in attenuator that you may or may not be using, and most scanners have an attenuator in them. like old ancient Radio Shack scanners had a 10 dB attenuation on the back.
I was having fun with that.
I know.
What my radio
I know.
has.
I think you were going down a rabbit hole there, brother.
I was. I had to like stop myself at 20. I'm like, this is going to go on for a lot longer than we have time for tonight.
So that's the other way you'd use attenuation besides in a fox and hound situation. And if you got somebody that's just 3 kilohertz over, blowing your doors off, maybe you want to talk to him, but you can cut him down, and it'll help with desense as well if you cut down some overpowering signal.
So my radio has 6, 12, and 18 on it.
Which radio is that?
It's the 3000.
3000.
Oh, okay.
I think on the, I don't remember, on the 7610, it's like a knob, and I can just dial it in. It's dial an attenuation.
John's saying 39 is the total on this thing. I don't know. Or is he asking me to do 39?
I'm probably asking
What
you to do
are you
39.
asking, John? Because I could do 39. That's doable.
Oh, yeah. What is the power limit on that attenuator, Steve? Did it say? Is it marked
It didn't
on there?
say for me, but you still have the screen pulled up. What does your screen say?
Well, let me open the documentation because it doesn't. Does it say here?
10 watts? Handles 5
10
watts
watts.
continuous and 10 watts intermittent.
Yeah.
Usable from DC to 200 megahertz. Good.
Which is probably a function of the resistor ratings in this thing. I'm not going to try and read resistor codes on stream because I'd have to open up another window to read resistor codes too. But
Okay, so I don't read resistor codes. I'm colorblind.
yeah, that's why I'm telling you. Well, I'm not colorblind. I just don't remember them. I have to look it up.
So, all right. So Richard is asking, what is the max limit? And the max limit is 41. And John is saying the max is 39. So either John knows something that I don't know, or John can't count. I don't know. All right. So what do we have? In order to get to 40, you do 20, 30, 5, 40, 1. All the switches down. 20 plus 10 plus 5 plus 3 plus 2 plus 1 is 41. So does that help, John, or am I still wrong? Tell me how you're right and I'm wrong. Because I'm not arguing. I'm politely debating.
I'm confused because, yeah. Oh, yeah, the power limit, Richard, is on the one on the web page right now is 10 watts.
Yeah, 10
you could-
intermittent, 5 continuous.
And you could kind of figure it out again by looking at the resistors in that. If you find something at Hamfest, you just need to figure out what the wattage rating is on those resistors.
Can you tell wattage rating on a resistor by looking at it? I thought you could tell the resistance value and the tolerance level. I didn't know you could tell, like, quality.
I think you can tell by size.
Awesome.
And truly, if you have ever seen one of those, they're like ceramic. Those things are high power.
John has conceded. I am victorious. John, I'm just having
John, I was excited. I was like, okay, there's some ham math guru stuff going on here. I'm missing.
I was hoping you were smarter than I was. I'm glad that we're on the same page, though. I'm glad that we're on equal smartness. So I think what happened was he only saw like so many of the switches and so many were off the screen. That's it. That's how it was.
Or your giant hand was in the way, or yeah.
Yeah. So it's really sad because the preview of the camera I have going on over here, I can see like every pore in my hand.
Mm-hmm.
And then when it shows up on stream, not so good.
I don't know how well
so-
this will show up. Yeah.
Put your hand behind it. There you
Probably
go.
too close.
It's good. There you go.
Let me turn on some light. So
I forgot to carry the other one. Wire wound resistors. Yeah, wire wound resistors would be a little stronger. We've
Yeah,
never
you talk
done this
about-
kind of thing before.
you talk about awkward. I don't know how well you can see the colors because I can't get the light in my hands.
It was actually better before. Because now you're bringing your blue screen in somehow. There you go.
We get the idea, Jim.
Well, I was trying to see the colors.
Wash your hands before stream next time.
Yeah.
My hand, that is an artifact of the light. See, my finger's perfectly clean. I'm just saying. My point was, so a lot of this you can eyeball by the size. Basically, the bigger it is, the more power it can handle, and there's a way to tell. And
So
I
you mean
think it's
thicker's
size
better?
related. Huh?
Girth is what you're going for?
Girth and length count.
So, Poto by Example wants to know what the website is for Pacific antennas. And it was qrpkits.com?
It
QRPkits.com.
was, or Pacific Antennas.
Well,
Yeah.
no, it
Brings
says that, but it's QRPkits.com is the
that-
URL.
That'll bring it up, though. I guarantee.
Oh,
it.
yeah, if you're Googling, yes. You Googled.
Jesse says that's not what my wife said. Okay, Jim, you wanted to show us something too.
So I don't have a fancy box-made gadget like Steve has. Can you make me full screen there?
I'm getting there.
Okay.
StreamYard's acting up because I'm seriously overtaxing my computer here.
It's a lot of jiggling going on that screen. Yeah.
Like
So-
Brown
gigawatts.
body 1 watt. Todd, you might be educating us somehow because I've seen brown bodies, I've seen blue bodies, and I've seen tan bodies.
Yeah, and I forgot about the color of the body. That's it. I knew I couldn't remember what it was because I don't fool with it enough to know.
Ladies and gentlemen, the role of the smoking ape will be played by Ham Radio DX tonight. We apologize for any inconvenience.
So what Steve has is rolling in and out resistors that change the value of the attenuation. All right. And just like in our taps that Ape and I did that we showed yesterday on Coffee and Ham Radio, all our resistive taps is a fixed resistor value. Ape used 3 820 ohms and I used 1 3000. I've got a bot. I'm going to try and lift this up and not unhook all this crap.
Oh, look, there you go.
Yeah. And then so what I did is I cut the resistor out of my box and have this switchable box in line.
Step 1, cut the resistor out of your box.
And now everything quit. Come on. Oh. See, I shouldn't have touched it.
I don't know, that looks better to me.
All right. Go do something else. Let me fix this. It didn't like me touching it. It's moved things around now.
Okay.
Just-
We're going to let Jim stay
I'll be
on
back.
center screen while he's embarrassed there.
Oh, thank you. Thank you so much.
Okay, so let me switch in the other camera and I'll show you something else that I've got, and I was kind of hoping that Jim would help out. What I've got is the tiny SA, and I realize that it's very tiny, but we, through the magic of television, can enhance. So I'm going to kind of do some of the similar things, but I'm going to do it live with this device, which is now giant over top of the tiny SA. And we're watching Jim make some magic go on there. So what I've got is the tiny SA, and I'm going to take it with a SMA to SO239. No, SMA to PL259 to SO239 to BNC to the what I hope is the output side.
Okay.
So that is connected to the, in theory, output side of this device. And then I'm going to take the included antenna, and I'm going to do the same kind of similar treatment. I've got BNC to SO239 to PL259 to SMA to the whip antenna that comes with the tiny SA. That's hard to hard to get centered on the screen when I'm not looking at the screen desk. So I'm going to plug that into
Did you
what
say
I believe.
whip?
I said whip. Plug that into what I believe is the input side. So
It
now,
doesn't. It shouldn't actually matter. It's just resistance.
Shouldn't.
It's going to be ambipolarity. Yes.
It should not matter. You are correct. So now I've got all that hooked up, and we've got that kind of off the screen, and I've got the world's best radio ever, Super Zoom on the Baofeng. Does it actually matter with an all-resistor device like that? Richard, no, it does not matter. So I'm going to put this onto some weird frequency that nobody uses around here, 146.52. And
Right. It's the
Move it
same
away.
down here.
And you can see that it jumps up. And if you look up here at the top of the screen, you'll see 146.52 is the center frequency. And if you look over here, you'll see the scale. And the scale is minus 20. So I
Well,
let
you-
go.
Your peak should have been, yeah, your scale is at minus 66 dBm. Yeah, that's like an offset. So you're scooching the scale up.
Well, what I did was I just turned off. I had it actually attenuating everything, so I just gave away the whole secret right there.
Did Ape not tell you to use Nano VNA Saver?
He did, but there's a problem with Mac OS, which is what I'm running, and the Tiny SA, which is why I've got the super zoom going on here. And also, he told me to upgrade the firmware, but I couldn't get the firmware upgraded in time for the show because I had actual work to do before this, and my boss would have gotten mad, and I have to live with my boss, and I don't like her when she's mad. So, all right, so back to what I had before was all of the switches in the attenuate position. So that was kind of giving it away. I'm moving the radio back because I don't want to overload anything.
Oh, you're on Tiny SA. I was thinking you're on Nano. I wasn't even paying attention. My bad.
Yeah. So now it's at 0 on the scale over here. And so I can start switching in. That's 1. It moved down a little bit. You can see it moved down. That's 1 plus 2 is 3. 1 plus 2 plus 3 is 6. And then the scale changed, which is why the number jumped. So now we're down to 10, minus 10. That's plus an additional 5. The scale changed. We jumped down to minus 20. Plus an additional 10. Now we're at 25. And then plus 20. And that last one's not doing much. I'm probably already attenuated out as far as I can go. Yeah, and if I bring the radio closer to the Tiny SA's antenna, we're at 0 again. So it seems to be doing the thing.
Doing the thing.
Tio made the right choices, not the awesome ones. All right, Jim, you look like you're rock steady there again.
Yes.
So let's get you embiggened.
At least it's rock steady until I look at it sideways. So
Don't look at it sideways.
the blue trace is bypassing any resistance at all. So what I've got is the signal generator that's built into the scope, putting out a 100 kilohertz signal at 250 millivolts for his amplitude. So that blue signal, and these are not set to the same scale. If you look in the bottom left corner, the yellow trace is at 100 millivolts for its scale, and the blue one is at 50. And we can change that. So let's see. Right? And that's changing the vertical scale, the amplitude scale on the yellow one. And I just want to point out they're different scales for one thing.
So Richard's asking which one is blue. The blue is the unmolested,
Blue
unattenuated signal.
Yeah, blue is unmolested. So what I'm going to do is I'm going to set the yellow one to match the blue one. Oops, got to go the right way.
So in other words, the bottom one.
Yeah.
And Dirk's asking, are the signals out of phase from each other?
We're not really paying attention to phase at this point. It's the same signal, but I'm doing it at 2 different test points. So yeah, there will be a slight phase difference.
The length of the tests? The length of the leads?
The length of the leads and what it's going through.
Velocity factor.
Right.
That would actually be a good explanation of velocity factor.
So, yeah, but it's so small it'd be negligible.
I can
So
see it.
we've got 10 ohms of resistance on the yellow trace, and you can see it's not the same size. And as I crank up the resistance on the yellow trace, you see how it's getting smaller and smaller. That's attenuation. That's attenuation. All I'm doing is rolling in more resistance here. And I have no way to make this 0 short of unplugging the resistor. But that's that's pretty much it. I can do this, and we can roll these together. And you can see there's a little difference in size, but no, Dirk, apparently the phase is pretty much dead on.
It's
It might
pretty close, yeah.
it might be a little out. Oops, wrong knob. But the biggest difference is going to be the amplitude, the up and down, the vertical axis. So, and again, so with the yellow trace now, if I start rolling in resistance,
Add some inductance, right?
you can see how, and yeah, I can stick my fat hand in here and jack things up a whole lot more.
Well, that's adding capacitance.
Yeah.
Oh, no, that's right, Jim. You're very magnetic. I'm sorry.
And then I can roll in, I can change it to the 10K side, and then the whole thing just goes away. Now, the thing is, so the scope is putting out a very low power signal compared to Steve's Magic Fang.
We are controlling the transmission.
Right. So that's it.
All right, so Don's asking me to get a little crazy and start using HF frequencies, and I don't know, can this thing do?
Well, the other one says 200 megahertz. Yeah, you can do HF. HF is lower than what you were keying on.
I was doing
Power.
146.
Yeah, that's
I'm not worried about
VHF.
the power, but the frequency range on the tiny SA is 100 kilohertz to 350 megahertz. Yeah, it'll do it. Okay.
Yes. Yeah.
Just needed to
I
make
would
sure.
turn down the power knob because I don't know what radio you're using. It may or may not go that low.
All right, so
Are you going
what
to
I'm
use the
gonna do-
6100 or something?
No, I'm going to use the 7300. I'm going full bore because that's how I roll. Let's
Turn it down.
yeah. Just turn it down.
Chuck and I'll entertain everyone with our dance moves while you're doing that.
So this is going to be hooked up to the DX commander. I'm going to go onto a band that's shut right now, but it shouldn't matter across the yard.
DX Commander.
Switch that over to some full key mode. Okay, so what are we going to do? I'm transmitting at 0 watts at 18100 on my frequency, and it's a little unclear, but that is 18 point something, 18.0. And what's the scale on that? So we've got no attenuation, and we're at minus 40. Is that making sense?
You're at minus 42. Yeah.
Yeah.
That
the
marker
scale
is
over
what, yeah, well, and it says up on top where your marker's at.
Ah, yep. Okay, so right up there, minus 40 dBm, and the 7100 is set to 7300. Sorry, is set to 0 RF power. So what I can do, I don't have enough fingers for this, I think. So I'm gonna switch in all of the attenuation. So we're at 41 dB down.
Have you got a dummy load on the other side?
No, it's just it's 17 meters, which is shut right now.
He's keying down, man.
Yeah.
And
You
the
did-
antenna's 100 feet away.
Okay. Oh, okay. You got to hook to an antenna. That's what I was.
Yeah.
And if
Okay,
you use
so-
CW, it would work better. You really want to key on CW, not sideband.
I'm keying on RIDI, similar.
Similar, close enough for Gummit.
I'm
Similar.
dropping a carrier at 0 watts. So 0% RF power. I've got all 41 dB step attenuating pixies in line, and instead of minus 42, you can see I'm not even bumping the scale at all. It's still at 68, so that's key up, and that's key down. So no change. So now I can move my hand over, and I can start rotating that power knob. And we're starting to get some signal. We're at minus 50. I'm at 20% output power on the 7300. So it's definitely doing the thing.
And how much attenuation do you have rolled in?
All 41.
Yeah, okay. Bueno.
Yeah, because I was just going to crank up. I'm at 35%. So we're at minus 71 now. And if I key down, minus 46 at 35% output power.
So let me pull up a chart. And there's a formula to do this, and it's not terribly convoluted, but there's about 8 million websites that will convert from watts to dBm and back. And as dBm is a logarithmic scale, it's a little, I'm math challenged, okay? I got through Algebra 1 barely. That covered it. So, Steve, what were you seeing when you keyed down with your attenuation rolled in?
Yeah, so we're at 41 dB attenuation rolled in. We're at minus 69 is the strongest signal at 241 megahertz. And then I key down, and we're at 18100 something, at minus 43. So minus 70 with no signal,
That's
minus 43 with key down.
it's 5.01 times 10 to the minus 8 watts. Because they didn't put this in milliwatts. So it's 0.000. It's a very small amount of power.
Tony, thanks for stopping by. Have a good night. Tony's leaving us early. All right, so I'm going to go back into power.
See you, Tony.
And turn that down. All right, so you can see that I'm at minus 60 at 0% output. And then let's... Yeah, okay. I'm starting to pull attenuation out. And it's starting to creep up again.
What's your output setting on the radio?
We're back at 0% out,
Okay.
which is great for SWR. My SWR is fantastic right now.
Right.
Okay, so we're at minus 40. And then I put in 1, and it's probably not going to be noticeable. No, it actually is. That's not bad. So that's 0 attenuation, 1 attenuation. And then there's 3. And then there's 6. So it's tracking pretty good, actually.
Yeah, it is.
So that's not bad for a $25 kit that I got at a Hamfest used for $12.
And you have the fancy one in the metal case because the one on the website looks like it's plastic.
It's actually caseless, and you got to print your own 3D printed case.
Yeah.
Now, Ape's asking me to do something awful tricky, and this is where I'm kind of out of my element. Where's Ape's question? He says, hook it to a nano VNA in a through config and do an S21 reading. And I think I know what he's saying. So let me get reconfigured for that. I'm going to turn off the tiny SA. I'm going to whip out the nano VNA. And so for the nano VNA, it should be both ends connected to the nano VNA.
Ape was supposed to be here tonight, but he had to talk to his CIA handlers and about that incident.
So
Can't say that.
there's the nano VNA.
Didn't say where he was at.
Nano VNA. And for the purposes of this demonstration, we're just trying to show a difference. So we don't really need to calibrate it. It just needs to reference a difference. So like if you've got a bathroom scale at home that's really horribly calibrated and it says you weigh, I don't know, something good like 200 pounds, and you weigh yourself the next day on the exact same scale and you're 2 pounds lighter, it's still 2 pounds lighter, even though the numbers are completely wrong. All right, so we've got nano VNA on. I'm going to switch out all the attenuation, so that's all off. And then we need to do an S21 reading, and Ape's going to have to help me out here. Ape, how do I do this from the front panel?
Yeah, I can't tell you. Because I use Saver.
Yeah, and I don't even have one of those things.
Should be stimulus. And do your start and stop frequencies.
So I guess it kind of doesn't matter. 7.
Yeah, do 40 meters. And then give it a stop of 7,400 or something. Yep.
Okay, and then I need to change the display. And I need to change that to trace. Turn off. Trace 1. And then I need to do format.
Turn off SWR.
Real, imaginative, back.
Log mag, he says, channel 1.
Yeah, log Mac. That's it. First one there,
Log
Steve.
back. Okay, so like that.
Perfect.
And then it should be reading in and out. So if I go... Okay, so move down a little bit. So that's switching in the 1 and switching out the 1. You can see it jump up and down. And then that noise is actually popping up right when I move the switch. That's the noise of the switch itself. Okay, so we've got 1 dB in. That's +2 is 3. That's +3 is 5. Plus 5 is 10. That didn't move as much as I thought it would. And then plus 10 is 20. That took a minute to settle down. And then we're at the full 41. So if I bypass it, it's got to be changing the scale. Okay, let's look at the scale. This is interesting. Okay, so we're in bypass mode now.
You're on
We're
channel
at-
0, Steve. You need to be on channel 1.
Okay, well, let's change channel.
Yeah. Hamdo saw that too. That's what Ape had said, channel 1, and I just caught that it said channel 0 up there in the top.
Channel.
Yeah. Channel 1 through.
All right, let's try that again. We're in bypass mode now. Let's switch
Crank it.
all 40 in.
Yeah. There you go,
minus
son.
39.
That's what we're talking about, Willis.
All right, let's pull 20 out. That looks about right. Put 20 back in. So 41 to... Stop that. Yeah, this is working great.
And it shows you your marker values there in the top center, Steve, in white right next to where it says logmag 10 dB.
Yeah, so it's showing that I'm at 7100. So if I move that...
Oh, well, yeah, your frequency, but now change your resistance. Add in all your attenuation. See? There's all your attenuation. Now take it all out. Do your bypass. Yeah.
That's
See?
the bypass.
The Nano VNA, people will bone on it because it's cheap and cloney, and there's a lot of
I like it.
clonies. But dang it, it does a lot of really cool stuff. And a real VNA starts at a couple grand for somebody's used garbage from the 80s.
So we have the Tiny SA, which is the same
Andy,
form
see ya, buddy.
factor as the Nano VNA. What I'm waiting for these guys to come out with next, and I would give them every bit of $50 for it, is the microscope. I would do that.
There are USB scopes, bud.
I know, but I want one in this form factor to complete the set. You would buy one, Jim. You know you'd buy one.
No, I have 4 scopes now, and I need to offload at least one of those, Steve.
All right, chat.
To a buddy.
What do you think? If the Nano VNA folks made a microscope, what's the over-under on Jim buying one?
Not happening, kids. Not happening. I don't need any more oscilloscopes.
You don't need any more?
I got 4, Chuck. I have 2 old plastic models, and I have my fancy one that I got about 6 months or a year ago when Ape and me were drunkenly speaking late at night in chat, and he made me buy that one. And then I got the other one that I bought like 2 months ago. Ape was involved in that purchase as well.
So I was
Sounds
just
like Abe is
looking
a
at
bad influence on you.
He's
I was
an
looking at
enabler.
R and L. They're 110, 125, $60, $90, and 110.
Keep talking, boys. I'll be right back. I want to grab
That is
something.
for the Nano VNAs, and then they have test kits.
Chuck, can you share out? My screen is still shared. Can you
I
flip
can't.
over? Oh,
Can't
okay.
do it, man. Can't do it.
I figured that was the
I
case.
can't do it, man.
I was going to,
Or I would. I'll be lucky to do it next week.
All right. What did you want to share, Jim? It's popping up.
okay, that's fine. I was going to look on,
Oh, AliExpress.
I'll make this
Yeah.
screen where I can actually see it. Yeah, Ape said he's interested if you could get the bandwidth, but the problem with a lot of these little ones is they don't have much bandwidth.
Oh,
See, that's $86 there.
That's not bad.
That says 120 meg bandwidth, XY mode, anti-burn, and a generator.
Anti-burn.
So the anti-burn, is that burning into the screen? Is that what that is?
I would guess so.
Since it doesn't have a burnable screen. All right, so I'm going to try something here.
I know
Jim.
you know what that means.
Yeah, I do. I've got my scope probes plugged in. Let's switch the screen back.
Probes. He's got the probes.
The probes.
Let's remove Jim's screen.
Air quotes.
StreamYard doesn't let you do this stuff behind the scenes and then switch it over. Okay, so what I did was I took the scope probes and I plugged them into the input and the output on the attenuator. And then I've got them hooked up to my meter leads. And then I've got my meter. Let's dust that off.
What?
Yeah.
Say that again. So you don't have anything generating a signal.
Well, I'm going to use this to measure resistance. You think that would do anything?
It has to put out it's putting out some voltage to measure resistance. It has to.
Well, the meter should put something out to get something back.
Yes.
So that's full attenuation mode. Yeah, it's changing. Let's turn it off across the board.
Oh, well, you said something about the oscilloscope. I thought you were trying to see this on the oscilloscope. And I'm like, the scope is not going to show you your resistance changing. Okay.
We'll be right back.
I thought you went full kook on that.
No. Okay, so multimeter plugged in using the scope probes in order to make the connection,
Okay.
the electrical connection. So I've got it in full bypass mode. We'll put it into attenuation mode. And I have 0 attenuation locked in. So that's 686.2. That's adding 1. That's adding 2, so that's 3. That's adding 3, so 3 plus 3 is 6. That's adding...
How much do you have rolled in total?
I just moved in 5 plus 6 is 11.
What did you start at?
I started at 0. And so that
Well, I mean,
5
when you
was
plugged...
weird.
Well, my point was
Right.
those resistors are probably not high precision resistors, so there's probably a fair amount of tolerance in those things.
Okay, so we're at full bypass mode right now, Jim. Ask away.
That's
I'll be
what I
your
wanted to
hands,
see.
Jim.
Huh?
I'll be your hands.
Well, that's just why that's all I was saying is, so let's call that 690-ish in full bypass.
So the 2 ground leads on the scope probes are flying. Should I connect those?
Yeah.
All right, those are now connected. That's a better reading. Right? It's all over the place now that the grounds are tied.
Well. Yeah, and APE is the multimeter's generating a signal. All right, so now roll in your attenuation. Try 1.
Okay, so that's 1. I went from 682 to 690. We're going to put in 2.
Oh, and you know what? That's in dB. I'm having a brain seizure anyway. You're rolling in dB of attenuation, which is adding resistance, but we don't know what the resistance is because we'd have to go look at the inside of the box.
Right.
I was like, that's off, and I don't expect it to be spot on, but man, that's getting weirdly off.
I expect it to change numbers.
Yes, absolutely, it will, and it's going to add more resistance as you roll in more attenuation.
I'm
Correct.
just hoping that we're having some fun here and that this is like bringing some light to some dark gray matter. Measure the DC resistance from center to ground. You should see 50 ohms no matter how much attenuation is set. I agree.
Right.
And so it's interesting that we're not really changing the ohms of resistance as much as I thought we were. So I'm full rolled in. That's 41 dB of resistance. That's unknown quantity of unknown value of resistors resistance, to be pedantic.
So is that from center to ground on your box?
No. I can do that though.
Let's do that.
So I'm going to unmarry the grounds. Let's move this to the right a little bit. Okay. So what I had before is the blue lead and the red lead are plugged into the input and the output. And
Now, you know those scope probes have a capacitor and resistors in them as well. So
Yeah.
that is jacking with everything you're doing as well.
Yeah, but this is just fun.
Okay.
So instead of plugging the tips of both probes into the tips of both meter probes, what you're saying is plug the ground into one, like that.
Well, I mean, you just take your meter probes. Forget the scope probes. Just take
Okay.
your meter probes.
I don't have enough hands for that. That's why I was hoping the scope probes would help out.
Well, you're throwing in a whole bunch of extra stuff.
I hear you.
Are they at 1x or 10x? Is that turned on or not? There's capacitance.
Okay, so you want
because-
center on one side and shield on the other side.
On the same connector, yeah.
You can't do the same connector. I mean, you can, but we're just reading the connector itself.
One probe in the center, one across the shield.
So that is where I'm at right now.
With no attenuation rolled in.
Well, it's only on one connector. It wouldn't matter if there was any attenuation rolled in or not.
Yes, it would.
So what the chat
Because
is
you're-
saying is that you should see 50 ohms if I connect the inside and the outside of the connector
Yes.
of one connector total.
Yes.
Get that on. Let me zoom this out a bit so we can get a little bit more on the workbench screen. Okay. So what they're saying to do is plug that into the center
Yep.
and plug that into the shield of the same connector, and you should see 50 ohms of resistance there.
It's not registering at all. Now,
And
do you have...
Tim's saying it's going to be 0 because it's open.
It's open. Okay, so roll
And
in...
Dave's saying do the other connector, which is also open at that point. And then Steven's saying probe the center of each, what do you call it? Probe the center of each BNC. And this is where I run out of hands.
There's your 50. Well,
I'm part of the circuit, I'm sure. All right, so I bypassed and I'm at 0 again. I put that in, and I have everything. I have the attenuator switched in, but I have all of the resistors switched out. We're seeing 50 occasionally, like right there. It just popped up again.
well, it's weird how it's jumping all over the place, and some of that may be... But you're touching the outside. You're not touching the probes.
Yeah, I'm touching the plastic on the probes and the outside of the metal case.
Do you have any BNC binding post connectors?
I do. Let me go see if I can find it. I think I know where it is.
I've got one right here if you need it.
I'd have to run out to the shop and dig them out of a box full of random connectors.
I actually, I have one right here. I was gonna say I usually have one sitting here. I got two actually.
Yes.
Dang, auto ranging meters. So since it measures open, that means that the attenuator is relying on one side being a 50 ohm load, the meter impedance. Okay, so I'm going to plug
Man, it's a tight fit.
that in there. I'm going to plug that in there.
WCB 640 seems to actually understand this much better than either one of us.
He is a very, very smart man.
We need him on
Broadcast
here.
engineer.
I kind of
Yeah.
figured that since that's not a ham radio call, it looked like potentially a GMRS or a broadcast radio.
Hey, if he wants to come on, I can make room for him, man.
So now we've got a much steadier reading, however, not very useful.
Hey, Gordo.
Hey, Gordo, what's up?
W1ECB is his ham call. You want to come on the stream, please?
Oh, he's been invited.
Okay. Send that man a link.
No, I mean he's been invited in general. He hasn't been invited tonight. I mean he's welcome to come on tonight. So we're at 0 megohms of resistance according to this meter right now. I think we're making negative progress, i.e. Congress.
And that's with no attenuation turned on.
Bypass mode. I mean nothing was turned on, but now we're fully in bypass mode.
Okay, so take it off bypass and pick a switch and flip it on.
5. Hey, there we go.
Okay. See, it's okay. Now it's settled down. Ish.
Connect a dummy load to see anything.
No, because that's going to put 50 ohms across the connectors. We should. You're seeing resistance now. I mean, there's. So turn on another dingus, or turn them all off.
I turned them all on.
Yeah.
All off goes straight to 0.
Oh my lord,
Okay.
the spam texts I've been getting the last 3 or 4 days.
-1. -3.
That guy said he was a Nigerian prince, and I'd get millions of dollars.
-3 more. -5. -10. And -41 goes crazy. So -41 is too strong for this meter to punch through.
Is he auto ranging on the resistance, or you got to change range? Because I see a range button there.
It's set to auto range right now. Now it's set to manual range.
Okay.
Where is my dummy load?
I find
can
those
put
auto-ranging ones go crazy
50
sometimes.
ohm dummy load on here.
Man, I had a good one on you at gym, but I was muted. Dang it.
Oh,
What was
Well-
that?
I forget now. Something about you getting spammed. I said you had to stay off those sites. But you actually answered like you heard me. So I was like,
Oh,
okay. So
Yeah,
now
I
I've got a
bet-
50 ohm dummy load on, and now it's 50 ohms.
yeah.
It's a 50 ohm reference standard. It's not technically a dummy load, but we're not putting enough signal through it to matter. Okay, so let's attenuate. 52.4, 52.4. So 1 doesn't make much difference. The more of this I switch in, the harder it should be for the meter to see the dummy load.
Well, you're just switching in more resistance. That's all you're doing.
But it's not measuring any more resistance.
Yeah. And so one suggestion was pick a pole on your
Yeah.
BNC adapter and then put one probe on the black connector on your fancy adapter, and then put the red probe in the center hole of the other connector. Take out your dummy load.
Okay.
Take your red probe or your black probe. I don't care. One of them probes.
Well, the
Well-
red
well,
probe is
which-
plugged into the black.
Okay. Well, then touch it to the shield and hold it on the shield on the other connector. No, the other
Over
connector.
here.
Yeah.
Okay.
Now, where are you at with your settings on the?
I am 41. The
Tim
resistors
saying
don't
there
go
was.
from signal to ground, so you won't see it that way. But we do. I'm switching all of the attenuation in and out. And either way,
Well,
what we're
he's
doing
right. So
now-
I know what Tim is saying. He's right.
Yeah.
He's right.
What-
So
what- hang on a
the
second,
resistance. Go
Tim.
ahead.
What we're doing right now is we're just experimenting. We're just playing. So, I mean, it's not like we're trying to be experts and show how intelligent we are, how dumb we are. We're just having fun with this thing because we've got
One of those
time to
things we're
kill.
doing. Yes. So we're both having a brain fart. Steve,
And-
I just built the darn thing. Yeah. The resistors are on the center pin. That's where all the resistance is. So if that which looks like a resistive tap, right? Now it's not as fancy as the one me and 8 built. In a way, ours is actually a little better because ours is a bypass resistive tap kind of deal. But that should have on the center pin wire should be where you're adding in all your resistances. And those are
Yes, that makes
calculated to
sense.
drop down power according to some formula. I don't know what that formula is. That didn't involve mathy stuff. Yeah, we're both having serious brain fart on this. So,
Yeah, so
there should be
real quick-
nothing on the shield.
Yeah, 2 feet. We have actually just finished doing all of that stuff. We did the tiny SA sweep and watched it go down. We did a nano VNA sweep and watched it go down.
Yeah.
Jim whipped out his oscilloscope and did a decade box, and we watched that go up and down. And now we're just playing. So we are now tapped center to center, and we are bypassing the attenuator. I'm going to turn the attenuator on with no attenuation tapped in, and there's a little bit of noise that happened. All right, so now we add in 1, and it went from 4 to 9. We take it back out. So 3 to 9. Add the 2, that's up to 20. Add the 3 is 36. Add the 5 is 60. Add the 10 is 92. And go all the way, we're at 106. So now we figured out how to make that work.
But now what I'm really confused about, and if somebody in the chat can explain it, so you read slight amount of resistance with it in bypass, and then as you turned on each separate switch, you're adding more resistance, but you're still only reading like 100 and something ohms, not K ohms.
Right.
So how is that getting 41 dB of attenuation with 100 ohms when the thing Ape and I built, Ape's was like 2,500 ohms and mine was 3,000 because I was lazy and used 1 resistor instead of 3. But that got us about 40 dB of attenuation from 2,500 to 3K ohms. And you've only got 100, and yet that does 41 dB. So somewhere there's a disconnect that I don't understand.
So RQ is giving the answer to the question that you just mentioned, AC and DC. I am now testing in DC mode, and you were talking about AC.
Yeah,
RF is AC.
Okay.
So that's the answer to that. Can you go back to that website, Jim?
But which one? I'm on the,
The Pacific Antennas website?
Yeah, I still got it up in the tab, I think. At least I hope that's not the pictures of what's her name. No, it's good.
Okay, so does it tell you anywhere, is there a downloadable instruction sheet or something that gives you the value of the resistors?
Yeah, probably right here.
No, I mean, RQ, you actually were correct. And we catch ourselves doing this a lot, where we start measuring RF in DC and wonder why it doesn't work like RF should work, because it's not a DC signal. And and Chuck will jump right in here on this one. That's the answer to why does balanced feeder line work differently than coax, and it's because it's an alternating signal, and the two of them are in opposite phases going down each of the opposite lines.
This is why I haven't passed
It
extra.
is correct.
I know
Stuff like
something.
this, man. Eli the Iceman. I got
He
that.
does.
I'm good on that, man. So, yeah. So there's your resistors. And none of
Okay.
those are large values.
And they're all 2 watts.
Yeah. So let's see. Is there
What are you looking for?
the schematic?
Oh.
Oh, that's a nice little chart now. Look at that. That's cool.
Oh yeah, that's what we just kind of tried to do.
Yes, and that tells you what your input. Yeah, there we go. Of course, it's that way.
Looks like it's a simple L pad. You know,
Yeah.
that was actually my thoughts exactly right there. I have no idea.
So the resistors that are. I wish there's a way to rotate this.
See the plus and minus at the top of the PDF screen? Right next
Yeah.
to plus and minus, there's that a rotate button.
Son of a gun.
I don't know, because I don't Windows. Hey, look at that.
This is Mac, you hippie. I'm a Mac guy.
Oh, well, Microsoft Edge. Sorry.
Well, that's true. I do switch hit. Okay. Well, it's a lot easier to read. So I was trying to figure out. So it's multiple resistors. Yeah, okay.
I'm totally picking up what you're putting down, Jim.
I'm thinking, and I'm not going to talk because I think I'm going to say something stupid, so I'm going to shut up.
Better to keep your mouth shut and have people think you're stupid than to open it and remove all doubt.
Yeah, that's exactly right. Well, I was trying to figure out if it was in series, because the thing Ape and I did was just resistors in series. I mean, that's literally what it was.
I'm a little confused by this diagram myself, but that's only because I'm probably overthinking it right now. But I think that you have some in parallel and some in series.
Yes, and I think that's what makes this. Yeah.
Think of each stage as a voltage divider that you are adding into the circuit total. Yep.
That makes sense.
What do you think, Chuck?
I don't know. I don't mess with this stuff as much as you guys do. You know what I mean?
%5 tolerance on the resistors. So brown resistors and tan resistors. So that would be different wattage ratings.
Man, Ron, check out the big brain on Ron. Ron's been sandbagging us this whole time.
Yeah, it's just been
It's a
laughing.
combination of the serial and the parallel resistors giving 50 ohms to ground, but from in to out, there is more resistance in each stage.
In each stage, yeah.
Probably been rolling around on the ground laughing the whole time.
So that's a much tighter design than that
Just kidding.
that one you have, because those are just push buttons to turn on the attenuation in and out. All 2-watt resistors, so I guess brown and tan are the same thing.
And Stephen is correct. From the schematic, it appears that each feeds into the next one, and it does, and that's how they are additive.
Right.
That is how you add them in.
So yeah, you have, each stage is in series with the next stage.
Ben is
And
saying
this
color
is-
doesn't matter.
It doesn't matter. Well, it says this says they're all 2-watt resistors. I don't know.
Yeah, so Ben, we were trying to figure out earlier how you can tell if it's a 1/4 watt resistor or a 2-watt resistor or a 10-watt resistor just by looking at it. And we don't know the answer to that question. But I think what we've done tonight is we've learned a lot about how these different step attenuators work, different ways you can use a step attenuator, and this QRPkits.com website is a fantastic looking website where you can get a lot of these things. And also, it definitely pays to drive 7 days to pick up a $12 discount on a step attenuator.
I mean,
knew that
that's
was
a
coming.
deal. That is a deal at any price.
Yeah, it is.
I got to go see the sun. That was actually very important. I hadn't seen the sun for a while.
Yeah.
And essentially, this is just a busy box. I'll sit it on my desk and I'll just play with it during meetings. I'm going to wear these switches out.
It's like those little things, the little balls you roll in your hand to keep yourself busy.
Yeah, that's a whole lot. That's a whole lot fancier than the thing Ape and I had, and it's like the Decade box, only super fancy. Because they've got the way he's done this. He's gone through and done all the calculations so that he's rolling in this much resistance for this stage, and that gives him X amount of attenuation. Ape and I just jammed a resistor in there, and the design came up with 40. I'm sure someone actually, and it probably says in the article, the mathy part of it.
So I will update the description in
Cool.
the screen with a link to QRPkits.com. I didn't think this was a kit build that you could do, but now it is, and it looked like when I got inside, it looked like it was built very well by whoever it was that built it before I got it. And yeah, it looks pretty good.
Well, it's interesting that design is using a plastic case. So on the things that Ape and I built, the shield is the case. It's a metal case.
Right.
Mine's in a custom junction box, and Ape's is in a fancy little stomp box. But
So I wonder if that has something to do with either A, that was just the case that was available, or B, the brass that's inside there requiring that.
the brass is hooked to the hot side, to the center pins.
Right. So I wonder
Hot,
if that size and shape and so on of brass is actually a mini antenna, is why it needs to be in a metal box. That's what I was thinking.
Wasn't there an antenna lead built into that?
Well, it's let me DC all this and I can show you. Well, it's basically two SO239s, one on either side of the box, and there's a brass strip hooked between the center pins of the of those two SO239 connectors. So on mine, hopefully that'll show up well enough.
Let's get you
Really.
embiggened. There
There we go. I have to put on the special light.
That looks good.
So on mine, the center pins, and this is the same design, it's just a different box, different layout. The center pins are what's hooked to the brass strip, and then I cut this out for tonight, but there was my 3,000 ohm resistor from there to the center pin down here on the BNC, and then this guy is a 50 ohm resistor from the shield to the center pin to provide the 50 ohm impedance for it. And the difference was, first of all, I bought the wrong size brass strip. It was supposed to be inch wide, and I screwed up and bought half inch. And then the box that Ape built it in, was just, I can't make my hand that way. A third the size and oriented differently. So I don't know that it's an antenna, and you're just passing RF across it. I think it's just a good conductor, maybe. I don't know.
I thought I remember him saying there was some kind of a tail in it that is an antenna. Maybe Ape's still here.
That little capacitance tail.
Yeah.
Yeah, and it's, it got cut off of mine when I clipped that resistor off.
So when you're building circuits like this, any open piece of metal of a certain length is an antenna, even if it is inside the circuit.
It is. And that's why I knew this was going to come up with different values than Ape got, because he had like really solid 40. And this was like a sketchy 38. I mean, it was still decent. But I had, this long resistor. I was literally, the leads were from here to all the way down. Can't figure out where I'm pointing to. From one end to the other across the middle of the box. So I don't know how much that affected it.
Gordo's asking, could you use copper? I think you could. It would just have to be a different size because of the velocity factor of copper versus the velocity factor of brass. Velocity factor is basically the inherent resistance in the medium. So either coax or copper wire or copper plate or brass plate or zinc alloy plate or whatever the case may be. It all has a different electrical property to it. If that makes any
But
sense.
if you're, this is an RF tap. That's all this is for.
Mm-hmm.
So that brass, in our case, the brass strip, or if you use copper, this is just so I can hook a dummy load on one side and a transmitter on the other, and this is where my pure RF is going across that. And then for this guy, then he's tapped those resistors off of there that go down to the BNC where my test equipment is at. I don't know if velocity factor, but
I think there's some
what you're
magic
trying to
the
do is
size of
attenuate
that
the power.
brass plate. Yeah.
And there may be. I got different results. I got 2 to 3 dB of difference from what Ape got on his. But he used the size that was spec'd out in the article, and he used the exact box that was spec'd out in the article, and mine is redneck ghetto fabulous. So, but it still taps, still a resistive tap. 38 dB down, I'm not going to complain. That's decent.
Yeah.
Or-
And Steve's saying it should be negligible, and you're absolutely correct. It should be. And I'm referencing the fact that in the documentation of the kit that they built, it very specifically said 1 inch by 2 inch or cube or something.
inch
along
by
those
inch and a
lines.
half. Inch by inch and a half. Mm-hmm.
So there was a very specific measurement that was given in the build instructions for the kit. And then Gordo's question was, if you used copper, would it be any different? And I think the answer is yes. And then the longer answer is, nah, not enough that it matters.
I don't think it's going to matter. And
Right.
I mean, yeah,
Not for
velocity
ham
factor.
work.
Well, velocity factor will be different, but if the speed of light across a piece of copper is 0.66 and the speed of light across a piece of brass is 0.68, okay.
So
You
it's an
can't
inch
tell
by an
the
inch and a
difference.
half of one, and it's an inch by an inch and 15/16 on the other one.
Yeah, I just
Yeah.
don't. I don't think it's going to matter. And ultimately, I don't think the velocity factor factors in really because you're not doing an SWR reading out of this. You're just trying to tap and see the signal.
Mm-hmm.
So I don't know. It'll work.
Yes.
Your mileage may vary, but it will work.
If you and your girlfriend are sitting on the couch together and you're at opposite ends of the couch, and each time you move half the distance closer to each other, will you ever be close enough to give her a kiss? The answer is no, but you
No,
get
you
close
won't.
enough to do what you want to do. Because
Still
we're not
pretty
talking about
close.
scientific instrumentation here.
Well, yeah, and I think I mentioned that in my video. This is not lab grade equipment here.
We're
If
not
y'all
going to the
wanna-
moon.
If y'all really, well, this is probably better than what they used. Yeah, if you want lab grade equipment, you're not going to use an electrical junction box and the cheapest parts you found on Amazon. But it is a tap. Now that cell wave tap, and Steve was showing this. Did you show it tonight?
I did.
Somewhere I watched the
Showed
video.
it Sunday.
Sunday. The cell wave tap is I mean it's even more simple.
It's not even
It's-
connected. It's just
yeah.
a loop of wire hanging over top of the metal plate that makes the dummy load itself.
Literally a loop of wire hanging over a wee small brass plate. There's almost nothing to it. And then a ginormous heat sink, and it's rated for 200 watts.
Mm-hmm.
So I think 100 continuous, 200 intermittent or something like that. And it was, do you remember, $20, 25, something like that?
Shipping was what got you because it comes from like Europe somewhere.
Mine? I don't know. I don't remember. I didn't think
Yeah.
mine did, but I don't know. That's how they
I swear
get you.
mine came from overseas. So WECB 640 in the chat is saying nope in all caps, and I think he's talking about the girlfriend question. Either that or he just said that everything we did for the last hour was completely wrong and don't believe a word of it. But luckily, we approached this from the angle of we don't know what we're doing in the first place. Let's have some fun, and I think we all had some fun. What do you think, Chuck?
And
I
Adam,
think so, yeah.
actually, Adam makes a very good point that I did not mention, and I might have said it in my video, and I don't know if Ape did. I don't remember. The attenuation is not
couch
going to
is
be
like big.
flat across the spectrum. It does change, and I did have that because I had mine on the spectrum analyzer, and the attenuation starts at 40 and kind of tapers off as the frequency goes up. I think by 200 megahertz, I was rising from 40 up to 37 or 38 dB. So yeah, it's not flat across a range. It changes across the frequency range. That's correct. And that's a very good point.
So I was afraid that we weren't going to get a full hour's worth of content out of this little tiny box, but that was definitely $12 worth of entertainment. So next week, we might do this one. We might do something else. I got a long list of things to do, and Jim wants to try the
yeah.
ham hotline. So if you are on the Toads Discord, we dropped a link in the Nuggets channel inside of the Toads Discord of what SIP phone to buy. The Ham Shack hotline, the Ham Shack hotline, is
HH.
literally, yeah, the HH is literally putting a voice over IP phone on your desk that speaks DMR when you pick it up, and you can get a phone number and it will ring. So if I pick up my SIP phone on my desk and dial your phone number, your phone will ring, and we can have a old-fashioned landline-esque style phone conversation. So these SIP phones are like $16.
You can
So-
Plasma, and I don't think he's in the chat. He found Mercari. I don't. That's
Yeah.
like a weird sell site.
It's like Banggood, Alibaba.
Okay, they had Cisco SIP phones that are on the approved list for like $15 with free shipping.
Yeah.
$16 with free shipping.
Make
And
sure
you
you
get-
get one that's on the approved list.
Get it
Make
on
sure
the
you
list.
Get a way to power it, and then I don't know what kind of cables do we need to connect it.
So you'll need an RJ45 connection. It's an Ethernet phone. It's not Wi-Fi.
to
To your router or a network cable.
so
Are you
this
talking
is
about
all
power
IP.
or-
No, I'm just talking
Yeah.
about how does it work, like RF. How do we
Oh,
get on
okay. So I don't know. We're going to discover some of that. The phones are IP phones. They are voice over IP. They are not landlines. They're internet phones. So you will need a network cable, and you will need access to a network jack, because without that, it's not going to do anything. And then the
Yes,
phones
PoE
also,
injector.
yeah, and for power, network connection, a hardline network connection, and then you need power. And if you buy one, when you buy one, you need to make sure that it says it comes with power, or you need to go find power. And I think most of them are probably like 24 volts. I can't remember. They may or may not come with a power brick. You can find power bricks on Amazon and eBay all day, or you need a PoE injector, or you need a PoE switch. Yes, what Steve just said. Anyway, PoE is power over Ethernet. If you have a fancy router switch combination, then all you got to do is plug your network cable in, and that'll light up the phone. That's what's used in most commercial voice over IP environments. And so Ham Shack Hotline is like a network of hams. You have to be a ham to get on Ham Shack Hotline. And then if I wanted to, I could dial Steve's phone number, and it would do a Jim to Steve phone call. And we could probably do party lines as well. And
And
it
there's
has
no RF involved.
well, it has a tie into DMR in some way that I have not explored yet. So yes, you can DMR call to or from DMR via the Ham Shack hotline.
Excellent. So that's coming up on a future episode of Nuggets as soon as enough of us, a critical mass of us, has the SIP phones, which is the name of the protocol. And we all report back in Nuggets that we're ready to do it, then we will all get together and do it. And you guys can ham along at home while we ham along on stream, and all of us can make complete fools of ourselves. So we'll see you
Right.
in the next episode, and we're going to continue to have more fun. I'm liking this new format. So we'll see you next time. Thanks, Jim. Thanks, Chuck.
Hey, thanks for
Welcome.
having me, man. Thanks everybody for showing up tonight.
Great time.
It's good. Good.